Hi, I'm Andrick. I'm going to graph this exponential function, g of x equals negative 3 e to the negative x minus 2. It's something that a lot of my students seem to be having trouble with. And maybe you're one of them. So here's how to do it. Let's start by looking at related functions and thinking about how a simple function like e to the x can be transformed into a more complex function like g of x equals negative 3 e to the negative x minus 2. So we'll start by thinking about just plain old f of x equals e to the x. And then we'll think about f of x equals e to the negative x, and then f of x equals negative 3 times e to the negative x, and then from there we'll get to this final function. So f of x equals e to the x, hopefully you know what it looks like. It just approaches 0 here and then shoots upward. It goes through the points 0, 1, and 1e is another kind of critical point for e to the x. Then 2e squared, 3e to the third, and so on. But it just grows faster and faster and goes up that way. But it does exist for all x values. It just gets really huge. So it's important to remember that even if we're on a small graph and it goes up off, it still continues to exist for these other x values over here. F of x equals e to the negative x, that's going to reflect the graph that I have over the y-axis, so I'll still have the point 0, 1 there, but instead of 1e, I'll have negative 1e. The x value gets changed to the opposite. Still shoots up towards infinity, still approaches 0 over here. Negative 3 times e to the negative x. What happens here is all the y values for all my points end up being multiplied by negative 3. So instead of having 0, 1, I'll have 0, negative 3 times 1. Well, that's 0, negative 3. And then also instead of having negative 1e, I'll have negative 1, negative 3 times e. That's negative 3e. So that gives me this graph. Notice that all these graphs have horizontal asymptotes at y equals 0. So I haven't shifted it anywhere, I've just flipped it around, and the asymptote hasn't really changed. But this last step, bringing in this minus 2, is going to take this entire graph and shift it down to. So that horizontal asymptote is going to change. It's not going to be x equals 0 anymore, it's going to be x equals negative 2 instead. So if I take these points and I shift them down to, I'm going to, let's go over to this graph. I'm going to start with this horizontal asymptote at y equals negative 2 right there. It's a dotted line, that's how I represent an asymptote. And that's what I expect the graph to approach as x approaches infinity. It's going to go through at 0, negative 5, since I took this 0, negative 3 and went down 2. And then this point will become negative 1, negative 3e minus 2. E is about 2.7, so 3e is about 8. So this is going to be very close to negative 1, negative 10. Not exactly, but close. And it looks like this, you can see this graph goes down very quickly, and then it goes up towards this horizontal asymptote. But remember, the function still exists for all these x values. There's no vertical asymptote for any exponential function. So it's just going to be very, very, very negative, but it still exists over here. There's no vertical asymptote, just the horizontal asymptote. Now graphing, so this is g of x. Graphing the inverse, we would flip everything. So again, that horizontal asymptote is y equals negative 2. Everything would be flipped, and so instead of having y equals negative 2 as the horizontal asymptote, I'd have a vertical asymptote. X is equal to negative 2. All my points would also switch. Instead of having 0, negative 5, I'd have negative 5, 0. And instead of having negative 1, negative 3e minus 2, I would have negative 3e minus 2. Remember, that's close to negative 10. Negative 1 right here. It would approach this vertical asymptote going upward. And you can see these graphs look like they're reflections over the line y equals x. So that's what it's going to look like. Now note so there's my y equals x line, so you can see the symmetry over that line. Remember, this logarithmic function, it exists only for x values right up until -2. Then it shoots up towards infinity, and it doesn't exist for any of these values, because any of these values would cause me to put a negative number into a logarithm, because the inverse is a logarithmic function. Now, I'd like to find the logarithmic function, so I'll go through the algebra over here to find it, and you can see how it wouldn't make sense to put these numbers into that logarithmic function. So finding the inverse, I start by just switching x and y. This becomes x, this becomes y. I have x equals -3 x equals -3 e to the negative y minus 2. And I want to isolate the y, so every step I'm going to take a step closer to having y by itself. First, I'll just add 2 to both sides of the equation. And then I'll have x plus 2 equals -3 e to the negative y. Next, I'll just divide both sides by -3 here. That way I get e to the something. I can't really apply a logarithm to both sides until I have it as a straight normal exponential function without anything added or multiplied times it. So I first have to get e to the negative y by itself, and then I can use logarithms. So if I divide both sides by -3, I get x plus 2 over -3 equals e to the negative y. Now I can take the logarithm. I'll take natural log because I have e as my base of the exponent. And that will give me just natural log of the left side equals natural log of the right side. But natural log of e to the negative y is just negative y. Because we know anytime we have natural log of e to the something, whatever that something is in the exponent, that's what natural log gives us as its output there. So I have log x plus 2 over -3 equals negative y. I want positive y, so I just multiply both sides by -1. And so I end up with negative log x plus 2 over -3 equals positive y, and that's going to be my inverse function. Finding domain and range of the two. If I want to find the domain of this original exponential functions always have domain equal to all real numbers, or -infinity to infinity. The range, though, only goes from -infinity up to -2. If I looked at this graph, it stopped at -2, right? So the range will just be -infinity to -2. Down here, the domain and range get switched because it's the inverse. So the domain of this function is the range of the previous one. And also, if I look at the graph here, the graph of the inverse goes from -infinity right up to -2, and then it ceases to exist for x values greater than -2. What would happen if I put in an x value like 0? I'd have log of a negative number. Logs of negative numbers don't make sense. So that's why, at this point, the logarithm ceases to exist, and so for all these x values, everything larger than -2, including -2, makes the function not exist. So the domain's only going to be values less than -2, -2 up to -infinity up to -2. The range, on the other hand, for the logarithm, it looks like it's going down very, very, very slowly, but it will go down to any y value you pick. So even though the logarithm is increasing with very little here, it seems, eventually it will get down there, even if you have to have x equals -2000 or something. Eventually it'll get down there, and the range is all real numbers. So we could write that -infinity to infinity, all the way down here, all the way up there. Or I could just write all real numbers with little r symbol. Okay, I hope this helps. Bye.